Hi guys, and in today's tutorial we will learn what is deep compositing, what is deep image, how to set up deep output from 3ds Max V-Ray, and later composite in Fusion. And let's see what are the advantages and disadvantages, and I hope you enjoy it. So here I am in Fusion, and before we start I would quickly try to explain. We usually work with z-depth data, distance from the camera to the object. You will get this channel, grayscale image, where the black represents the further distance, white color represents the closer to the camera distance. It looks like this. So here's my camera, and here is let's say that's geometry in my 3D scene, this plane. Actually this should be a 3D object. So what the camera sees and saves out as a Z channel, Z depth channel, is this. So it shoots one ray from the camera, it reaches the geometry, the surface, and saving out this data. This data will look like just a Z channel, a depth channel, which is represented by Z letter. And this is it. There is no information about the color, no RGB, and no alpha. So this is what we got. And that's Z depth. With deep data, we will have the following stuff. So this is the camera, this is my geometry, and what happens here is camera shoots the ray till the point it reaches the geometry and saves out this information as RGB. So that's a color information about this object. Also alpha, how transparent that object would be, and also Z channel, the depth. And that's good. That's a bit more than this, of course. But what happens if we have not the solid object, or for instance semi-transparent object? It means that here in this case, if our box is semi-transparent, we will not get that information from that back wall. On the other hand, with the deep data, we can get that data from the behind wall. From that point, let me colorize it. We also can store that data in the output image, and this will be represented as a new set of data. Same channels, but different values. And that's the whole point of this thing. It means that on compositing stage, here we cannot get that. On the compositing stage, we can comp objects one after each other, because that image stores the information about how far from the camera objects are being in the scene, although they've been rendered already. And same will happen if we have any volumetric effect. If, let's say, we have a cloud, if we, here's my camera again. Oh, come on. if we have a cloud, this object is volumetric. It means that it has outer shell, but also has information inside it, the density. The closer to the center of this cloud, the more density this cloud will have. It means that every time we shoot the ray from the camera, it reaches each point of that cloud through it. And each point, every slice or layer you will see later, can be stored as a separate set of data with different values. And that is the true power of deep compositing. Of course, it means that our files will be much larger than usual output, because first of all we save EXRs, and second of all we store a huge amount of data, because we are not only having this one array of points, we also have them here and the points behind them, and that's actually a grid. But let's finish with the theory and check on the real example. So here I have my loader, and I rendered one scene. Let me show it as a JPEG first, because now we see an EXR. And I will rename my node and load the JPEG image. A pretty simple scene, nothing special. I just made it quickly for the presentation. It's static scene, camera is not moving. What we see now is a JPEG and EXR. This EXR stores deep data. We can see it up there. It's written here. And if you load JPEG, it's just a integer 8-bit. So let me just show how it looks. Let me drop the node, which is called deep to points. This node allows you to represent that deep information that image has in 3D space. That's actually a 3D node, and currently it's stretched out because we need also a camera. It's better to have camera that you used for rendering this image, but in my case I can just create a default camera here and plug it. Now it looks a bit more realistic. We can adjust how deep and how far it is from the camera, these points, by just adjusting angle of view. And as you can see, these points has no color yet, and I made it intentionally because if you exclude RGB data from EXR with deep data, the file size will be smaller, but to bring back the information about the color, we can just create a node, deep recolor. So recolor, and plug our EXR with deep data to the yellow input and the JPEG color information to the green input. And this way we can have a colored image. And if we check in the deep to point, now we see everything in color. In a deep to point, we can adjust the points, the size of them, and the density. Of course, the more density you have, the slower the performance. So I would keep it by default 0.1. You can't actually do a lot with these points. We needed just to represent the the data and represent the distances between objects. So first, what I wanted to show you is, besides these the scene, I also rendered separately the Atmo pass. This is I will show you in the max file how it looks, but this is just a container with the fog, V-Ray volume fog. And let me drop it here. So copy, and I'm gonna call it Atmo EXR. I would not recommend to put this data, this atmospheric effect, into deep to points, because it's gonna be very slow, because the whole scene is filled up with the points and the points behind the points. So you can imagine how difficult for the software to calculate this. But we can try. And also it has no color. It's the same approach. So I rendered without any RGB channel, just a deep, just a depth data. And recolorized again. So deep recolor node. And let's try to put it in the deep to points. Yeah, for some reason, I don't know why yet, but here you have to make it renderable to see the color of these volumetric effects. Without make it renderable, you will see still black points instead of colored. It doesn't give you much, and you can combine these two type of informations, these two rendered layers. So the main scene, let's call it like that, and volumetric effect, by creating a deep merge node. It's similar to the regular merge node. We can plug as many layers we want. It can handle many. So this is we combining them together and see the final output. And let me plug that to the deep to points and see in the viewport. So here you see them together, and it's not very useful, although it looks cool in my opinion. You can also enable this option, transparency, and that will make it just look better, slower as well. So let's go back. So having this, let me show you something cool. Let me create deep transform node, and I'm plugging it after my Atmo pass recolored. So I put it here. With this deep transform, you can manipulate this data in space, so move it further from the camera or closer to it. Let's just try it. So I select the D transform and translate by Z, distance from the camera. I'm gonna put the quite high number, so it's 5,000, let's say. And as you can see, the fog, the mist moved back. But if I will bring it back slowly, you will see how the fog going through the space and actually understands that it is behind the trees. After some point, it's in front of the tree. So just imagine if you have only Z depth channel, and if you will try to put something inside the fog, you will not be able to do that with just that data. But with deep data, you can put inside in between the pixels. So far so good. And now I also have one more layer I rendered again separately. That's a volumetric effect. Let me bring it here into the scene. That's a little steam from the manhole. Again, I rendered it without any RGB, so let me bring here the color. Again, that's gonna be JPEG. This is how it looks. I rendered it over the black background, and also the geometry I had beneath this fog. I had it as a shadow catcher in my mock scene. So let's use the pre-color node. So color is there, and if I want to see it in deep to point, I can do that. Here it is. Yeah, let me just untick the make renderable to make renderable, because I want to show you what actually that image has, that the XR image has inside. I have that geometry which was just overridden the black material, and because I wanted to keep it in the scene, in the render, to cast shadow on my volumetric effect, but to keep it black to make it transparent later. But the information about geometry is stored in deep data. I don't need that. Yes, I can clip it by just creating a deep crop node, and I can put it right before the deep blue points and adjust the distance. For example, the maximum can be 800, maybe that's enough, and close distance something like 50, or that's not enough, 200, maybe 400. So now we have only the part of that deep data we need, not everything together. I can make it renderable, and it will be faster, this scene. Let's merge this volumetric effect to the main scene. I'm going to unplug my deep 2 points. I don't need that. And this is my main deep merge node. I merge it there and see together, all together. So what can we do with that? Again, we can recolorize if we need to modify the color of the fog or steam. What also we can do is to comp flat image, which is not a deep image, behind or inside that steam. This is quite cool. Let me show you. So I have let me load my image, and that's a cat. We actually have a node which is called image to deep. And this node helps you to convert any flat image into deep image. Yeah, here you can see that it's been converted. In theory, this node should help us to merge this image to the deep information, but I found out that even without this node, you can plug directly to the deep merge, and it will automatically convert any flat image, which is super cool. So having this image of the cat, we can check it in the deep data. in dip to point, sorry. Let me move it here and plug this dip, but not this dip merge. I don't want to merge the Atmo pass together. So I will just create a new one, deep merge, demerge node. Put there my main scene, sorry, my Steam, and the cat. And all that can go to deep to points. Sorry. Like so. We don't see the cat now because we need to scale it up, I believe. So let's create a deep transform node, put it after the cat, and adjust the size. And let's move the image of the cat from the camera. Translate by z-axis, translate to 500. Yeah, it's too big. Size 1 would be very enough. We can move it further, and that will intersect exactly with the fog and will appear inside. Let's move it by X and Y. So here we see them in space, and here if we check the deep merge node, we see them together. So the cat now is inside, and we can translate it back and forth. Isn't it cool? Let's put now this translated cat to the main scene, so I can unplug from this temporary merge node, delete, unplug from deep to points, and check in the deep merge. Yeah, and we need to plug our D-transform instead of the original image. And now we have that cat in the proper place. We can scale it down now by changing the size, put it on the ground. We actually can put it under the ground because again, we store data about the geometry and depth from the camera. We can put that cat anywhere in the scene we want, behind that trash. Currently the camera is not moving, it's still, but it's still possible to have this plane of this cat, this image plane in 3D space, and it will react accordingly to the camera movement if we would have moving camera. But I think I will do it in the next tutorial. Do not overload this one. I think it's a good time now to move to 3ds Max scene and see the setup of this deep data output. Alright, I used 4 setups in my scene manager, and this main one is what you saw as this image. And as you remember, the EXR file was totally black. It's missing the RGB information, and that's easily can be done through the render elements. I would recommend you to read one page of V-Ray documents about this render element, V-Ray option RE. You can find it here in the list. with this render element, actually it's not renderable thing, but it needs to set up the EXR file. V-Ray frame buffer enabled by default, so it will bake all the setups from the frame buffer for all the adjustments. The filtering is the compression is EXR compression. For us, for our purposes, what I've done in comp in Fusion right now, DWAA compression, this is what we should use. EXR data window, it will render either region if you have region selected in your render. That actually can help to reduce the size of the file. I haven't tried it though. So by default it's this, but you can set up auto or the whole image. Multipart, EXR multipart will help to play EXR files faster, and yeah, so usually actually it's must have, I think, to enable it. Deep merge fragment mode, if you set up, let's say, by render ID, it will use each object position in space and will write it out, but the space between the objects will not be baked into deep data. But if you specify by Z depth, the file will be a little bit larger, but you will have more data, more of those slices in between the objects, because we're using not the objects for sampling the distance, but the Z depth values. None will save without any fragmenting. That's the largest file you can output. I would not recommend to do that. And by render ID and ZDEP, that's a combination of two. Merge ZDEP threshold. I'm not fully understand this, but from what I've read, that you can, by changing this value, you can tell if these 2 points are close to each other. You can merge them together and in easy depth, and that will reduce the size of the file and will reduce amount of samples in deep data. About the deep alpha colors, monochrome, RGB, or both. I used monochrome and that was enough for me. Not sure actually what's the difference. Again, you can check in that document. And exclude RGB from deep files. This is what I used to get that lighter EXR file, but without any color information, which I got that color from the JPEG with the recolor node. Let's check the setup for the atmosphere. So here I have main and Atmo, two setups. For the Atmo, I used again monochrome, removed RGB and used by ZDepth. But I think for the main, I used by render ID. So these files are smaller than these by ZDepth, but these have more data inside. I hope that was more or less clear, and I think I'm gonna make one more tutorial or maybe two about, I will use another scene, I will use the moving camera. I want to discover this topic more, and I invite you to join me in this. So thank you, see you in the next one.